All right. Good afternoon, Anna, Jonathan, Charles, and Oriel. Thank you for joining me this afternoon. So today we'll try to finish unit number 4. Talagang ang iksi ng unit number 4, ano? Kasi we mentioned that unit 4 will just be sort of a revisit for our way of revisiting derivatives. Tapos nakita nyo last time, walang malaking pagbabago dun sa treatment natin ng derivatives. Unlike yung limits na medyo generalize natin yung konsepto ng limits mula sa Math 36. Pero kung mapapansin niyo yung differentiation o yung definition natin ng derivatives for Math 155 is exactly what we had in Math 36. So little adjustments need to be done, and that's the reason why we won't focus on revisiting ano yung mga theorems, mga techniques na discuss nyo sa Math 36. Kasi nga extension lang naman sila, or actually hindi nga extension, sila rin yung mga theorems na mag-work dito sa treatment natin ng derivatives in Math 155. So the goal really of this unit is to focus more on the theoretical and the significant theoretical results or theorems that stems from the concept of the derivative of a function. Medyo ang tangi lang siguro ang kaibahan nito ay nagkaroon tayo ng additional tools. Kasi you remember, derivatives are just the limit of a difference quotient. And we have now a set of brand new tools paano mag-deal with limits. So pwede nyong i-adapt yon para sa konsepto ng derivatives. But essentially, all other techniques that you learned in your elementary calculus classes still hold, still apply, in the same way as they did in Math 36. So pwede nyo siyang gamitin without the requirement for a proof, unless siya talaga yung pinapaprove ko. So that means kung sa problem set or sa homeworks ay meron ako ipapakompute na derivative, pwede nyo gamitin yung mga techniques na natutunan nyo na from Math 36 without worrying about providing a proof. Okay? So, but before we continue our discussion today, medyo napahaba yung intro. Sesegue ko sana kanina dun sa announcement. As I was saying before the recording started, I am extending the deadline for the second problem set. So instead of the deadline being tomorrow, right before midnight, I'll move it to Sunday, the 15th of May, 11:59 p.m. Okay, to give you some more time. Kasi alam ko, nalaman ko na medyo sabay-sabay pala yung mga ginagawa nyo. But I cannot extend it more because we are done with unit 4, we'll be done with unit number 4 today. So I am thinking of giving you a homework, a short homework, katulad ng mga homework natin dati on Monday. Okay, and I'll give you a couple of days to finish it. Maiksi lang naman, no? Though I apologize, hindi ko pa rin nagagalaw yung homework number 5 due to my connectivity issues yesterday at hindi na nga ako ginahanahang magtrabaho. But I'll try to finish it probably tomorrow. Okay, kakalendaryo ko na siya bukas. And then, yeah, you'll have brand new homework on Monday around 8 a.m. I'll make it live on Canvas, and the deadline would be on Wednesday right before midnight. Okay? So I think that takes care of our preliminaries. So we will now continue our discussion, and I guess we left off with the interior extremum theorem from last time. Sabi natin itong interior extremum theorem ay ito yung basihan ng optimization technique that was taught in Math 36 na sabi natin ang mga relative extrema, mapa minimum yan or maximum, ay nangyayari lamang sa mga points kung saan ang derivative ay equal kay 0. That's why in Math 36, our first step in optimization is to take the derivative, equate it to 0, and the roots of that equation will be what we call the critical numbers. And the critical numbers are the possible candidates para maging relative maximum or relative minimum. And essentially, that's what the interior extremum theorem is telling us, okay? But the another nice thing about the interior extremum theorem is it gives us a disqualification para maging isang maximum or minimum. Pag tinignan natin yung contrapositive ng theorem 4.4, so what will that read? It will read that suppose that if f prime is not equal to 0, then f cannot attain a maximum or a minimum at the point x sub 0. So ang derivative ay hindi zero sa isang interior point sa isang open interval, ibig sabihin hindi siya pwedeng magbigay ng relative minimum or relative maximum. Kaya na-single out natin sa 36 na ito lamang yung mga posibleng magbigay ng relative extrema. Okay? Kaya lang relative extrema ito kasi yung interior extremum theorem only talks about the behavior at an interval, at an open interval AB in particular. Now, yung contrapositive na to ay medyo i-generalize ko into lemma 4.1. Ang sinasabi ng lemma 4.1 ay katulad ng conclusion ng contrapositive, pero here it will talk about the behavior at the endpoints, okay? So if we assume that the function g is differentiable on the closed interval AB, and if the derivative at the endpoints are not equal to zero, specifically if g prime of A is negative, while g prime of B is positive, then the endpoints cannot give us a relative minimum or an absolute minimum. Because this is saying that there exists two numbers, x and y, in the open interval AB, such that the function value at x is smaller than the function value at A, and the function value at g is less than the function value at B. So essentially, ang sinasabi ng lemma 4.1, sorry. Ang sinasabi ng lemma 4.1, kapag hindi zero yung derivative dun sa dalawang endpoints ng closed interval, then the absolute extrema, specifically the absolute minimum, cannot be at A nor at B. All right, so imposible. Right, and this completes yung contrapositive no and this with a contrapositive of the interior extremum theorem will give us yung idea na hindi pwede magkaroon ng absolute max kung hindi zero yung derivative, and also for the absolute minimum. Okay, so the proof is left to you as an exercise because as this is called a lemma, ang value niya ay pang-prove ng isang major theorem. And that major theorem is what we call Darbo's theorem for the derivative. Actually, Darbo's theorem for the derivative is sort of a version of the intermediate value theorem para naman sa f prime, para sa derivative. So pinapakita nito na merong napopossess na intermediate value property yung derivative ng isang function f. However, it will not require f prime to be differentiable kasi kung ang function, f prime to be continuous. Kasi kung yung function nating f prime ay continuous, then pwede natin gamitin yung intermediate value theorem. That means for every number between f prime of A and f prime of B, there exists a number C on the interval AB such that f prime at C is equal to the intermediate value, say alpha. Okay? So straightforward yon. Pero sabi ni Darbo, hindi mo kailangan na continuous yung f prime. Yung differentiability lamang ni f ay sufficient na para masatisfy yung intermediate value property. Okay? So in particular, we will assume that the function f is differentiable on the open interval AB. And alpha is a number that is strictly between f prime of A and f prime of B. Actually, it doesn't matter if f prime of f prime of A is less than alpha, and f prime of B is greater than alpha. So basta si alpha ay nasa pagitan ng dalawang values. Okay? Nung function values and derivative dun sa magkabilang endpoint. Then Darbo's theorem is telling us that if those two conditions are met, then we're sure that there exists a number C on the open interval AB such that the function value, there's a typo here, hindi talaga nauubos yung mga typo. Sorry about that. That f prime of C ay equal kay alpha. Okay? So para talagang kamukha siya ng intermediate value theorem. Okay? Now, yun pala, nag-upload ako ng bagong version kanina, mga around 10 or 11 a.m. Kaya lang, meron pa akong mga corrections na hindi pala na factor in. Ano? So yeah, probably I'll send out corrections later again. Okay. So now let's look at the proof of Darbo's theorem. So ito yung makita na naman natin dito sa Darbo's theorem or sa proof niya, yung isang common theme sa mga proof sa analysis. kadalasan kailangan nating magsimula with a specifically crafted function or object kung saan pwede nating i-apply yung mga iba't ibang theorems. Okay? And usually, if you are reading the proof, it won't make sense kung babasahin mo lang, oh sir, bakit sa lahat ng function g na pwede kong i-define, bakit tinefine ko siya as f of x minus alpha x? So, for these cases, don't fret too much or don't feel bad if you don't see bakit ito yung kailangan. Kasi marirealize natin kung bakit siya yung ginamit as we read the proof all along because they are constructed for the sake of what is to follow. Okay? Pero as we go along, as you read such proofs, nagiging familiar kayo sa mga techniques o mga galawan sa analysis, minsan marirealize nyo, oo nga, ganun siya tiningnan. For instance here, our target is to show that f prime of c is equal to alpha, or we want to prove the existence of a number c such that f prime of c is alpha. So dapat yung derivative ay nagiging equal kay alpha sa isang number c dun sa open interval. Okay? So if you look at the function g, pag kinuha ko yung derivative niyan, magiging f prime, so g prime ay equals to f prime minus alpha. And remember, I want to find the c such that f prime of c is equal to alpha. And that is equivalent to finding a number c, okay, who is a root of g prime. Kasi pag si g prime ay naging 0 kay c, ibig sabihin si f prime at c minus alpha ay equal rin kay 0. Transposing the alpha to the other side will give us f prime equals alpha for that particular value of c. Kaya siya napilitan na, okay, ito kaya yung i-consider ko. And if that is my function g, then my goal now is to show that g prime is equal to 0 for some number c in the interval ab. So yun yung gusto nating gamitin. Tapos ano nga ba yung pwede nating gamitin para mapakita na si g prime at c ay equal kay 0? Well, actually, pwede kong gamitin yung ano ba? Interior Extremum theorem, pwede rin ang Extreme Value Theorem, and I guess the proof here used the Extreme Value Theorem. Okay? So i-analyze natin. So kung ito si G, okay? So G is actually the difference of two differentiable functions. F is assumed to be differentiable on the interval AB, and alpha x is a polynomial, okay? Polynomial chain x, so it is differentiable everywhere. So G, being the difference of two differentiable functions, is also differentiable. Okay, so you can glean that from results from Math 36, or basically you can prove that assertion using the algebraic derivative theorems we have proven last time. Okay, and not only that, since G has a nice form, we can calculate its derivative easily. So we can see that G prime, as I have noted earlier, is f prime of x minus alpha. Okay. Now, so since f prime of x minus alpha is the derivative of g, sorry. So dahil yan yung, dahil na-compute natin yung derivative, tingnan natin ano pa yung pwede nating magamit mula dun sa mga assumptions. Note that this proof assumes that this is true. Okay, ito yung relation. If it's the other way around, then you can write an analogous proof. Okay, so madali siyang i-adjust. Pero in this particular proof, ito yung kinonsider natin na case. The second case will follow similarly. Okay? Now, kung totoo ito, kung si f prime of a ay mas maliit kay alpha, so si g prime of a, tingnan natin ano mangyayari kay g prime of a. So si g prime of a ay equals to f prime of a minus alpha, pero si f prime of a ay mas maliit kaysa kay alpha from this assumption. So therefore, this guy is negative. Tama? Kasi nga, mas malaki itong f prime of a kaysa kay alpha. So g prime of a is negative. On the other hand, if we know that alpha is smaller than f of b, so if I plug in b here, g prime of b will then be f prime of b minus alpha. Oh, sorry, another typo. So meron tayo dito ay f prime of b. So dahil si f prime of b ay mas malaki kay alpha, so yung g prime of b ay magiging positive naman kasi ito ay mas malaki kaysa kay alpha. So we have this relationship. And this is nice because we can use lemma 4.1. Kaya nga siya lemma eh. Yun yung hint dito. Pag nagbabasa kayo ng book, merong lemma bago ang theorem, malamang sa malamang yung lemma na yun gagamitin ko dun sa theorem. Okay? And that's why we also written this way. Bakit hindi alpha x minus f of x? Right? So kasi gusto ko maging eksakto na mapapasok siya doon sa assumptions ng lemma. Okay? So this is true. And then since G is differentiable on AB, then it is continuous on AB. Next ano na pala to, no? Next sentence. Pero sige, nasira yung flow ko. Alright. So halatang hindi ako yung nagsulat ng proof. Ano? So kasi dito, eksaktong dito, makukonclude ko na si G ay hindi pwedeng mag-attain ng maximum, ng minimum kay A at saka kay B by lemma 4.1, right? So since all the assumptions of lemma 4.1 are met, and so we know that G cannot attain the minimum at A nor B. Kasi nga hindi zero yung derivative dun sa dalawang endpoints, so disqualified na sila sa pagbibigay ng absolute minimum. Okay? So therefore, but on the other hand, we know that G is differentiable on the closed interval AB, and so it is continuous on the closed interval AB. So ito yung theorem 4.1, differentiability implies continuity. And the closed interval AB is compact. Minimum and the maximum at a point in the closed interval AB. Alright, so yun yung sinabi ng MVT. Magkakaroon siya ng minimum dito sa closed interval AB. Tapos, dahil nagkaroon na siya ng minimum, kaya lang ngayon alam ko na imposible na yung minimum ay mangyari kay A o kaya kay B. So that means we know that there exists, or that minimum, that number C will be on the open interval AB. Kasi nga disqualified na si A at saka si B sa pagbibigay ng absolute minimum. So the number C guaranteed by the continuity of G on the compact set closed interval AB, all right, is sufficient to say na, okay, si C ay dapat nandun sa open interval AB. Okay? At kung yung absolute minimum ay na kay C, that means G prime of C must be equal to 0. Okay? Kasi nga siya yung minimum, so necessarily ang derivative ay equals sa 0 by the interior extremum theorem. Okay? And then we already computed G prime. Denote na natin to kanina. So this is equal to F prime of C minus alpha. Transposing alpha to the other side will give us the desired identity. F prime of C equals alpha. And so that ends the proof of Darbo's theorem. Okay? So is that clear, guys? Questions? Because if you have none, then this closes section 4.1. Diretso na tayo dun sa second half ng Unit 4, which is a discussion of the Mean Value Theorem. Okay? So ito yung isa siguro sa mga feeling nyo ng Math 36 na pahirap lamang. Kasi hindi apparent dun sa treatment niya sa Math 30 series yung value ng Mean Value Theorem o yung significance niya. Right? But here we will see that the Mean Value Theorem actually allowed us to develop some powerful tools in calculus. Halimbawa, makikita natin later na yung Mean Value Theorem pala ang naging basihan ng L'Hopital's rule, or it's one of the major ingredients sa proof ng L'Hopital's rule. Okay? Pero sa Math 36, kontento tayo sa paghahanap ng number C na ginagaranti ng Mean Value Theorem. Ano? So hindi natin nakita yung kanya talagang significance. So in the long run, as we learn more, saka natin nakikita kung ano yung value ng mga bagay na siguro ini-ignore lang natin nung mga unang panahon, when we do not have the wisdom to learn wisdom about more profound things. Okay, now we will start the discussion by one major theorem. Ito yung tinatawag natin na Rolle's theorem. Okay, so ang sabi ng Rolle's theorem, we are considering a function f that is continuous on a closed interval AB and differentiable on the open interval AB. And if in the off chance that f of A is equal to f of B, then we are sure that there exists a number C on the open interval AB such that f prime of C is equal to 0. Okay. Now, kung titingnan natin yung drawing ng Rolle's theorem, ito ay isa sa mga paborito kong theorems na dinidiscuss sa Math 36 kasi ang dali niyang maintindihan graphically. Okay. So meron tayong A, meron tayong B dyan. Tapos ang assumption, si F ay differentiable sa closed interval AB at continuous sa open interval AB. So ibig sabihin yung function niya ay smooth at continuous mula sa A papunta kay B. And not just that, we have the assumption that f of A should be equal to f of B. So f of A equal dapat kay f of B kunwari. Tapos dapat smooth and continuous yung graph. So drawing ka dyan ng kahit anong smooth continuous graph na gusto mo. Alright? The guarantee ng Rolle's theorem ay makakakita tayo ng isang point doon sa domain na ang slope ng tangent line ay equal kay 0. Remember, f prime of C is just the limit of the difference quotient. And we said last time, or when we met the derivative, yung difference quotient, siya lang yung nagre-represent ng slope between 2 points dahil nagli-limit tayo habang yung dalawang points ay palapit ng palapit sa isa't isa. So nagiging isa na lamang siyang tangent line from a secant line, right? So that means the derivative is equal to 0. Then we are sure that there exists a point on the curve where the tangent line is horizontal. And in that particular case, mukhang ito yung, oops. Ayan, sorry, nag-overlap na siya. So yun yung point, malapit dun sa y equals 0, yung tangent line. So we find, and this is the number C, na ginagarantiyahan noong Rolle's theorem. Okay? So let's try to prove Rolle's theorem because this is a very important ingredient kasi makikita nyo mamaya yung mean value theorem, even though siya ay mas general kaysa kay Rolle's theorem, yung proof naman ng mean value theorem ay nagdepende dito sa napakaliit na theorem, dito sa specific theorem na Rolle's theorem. Okay? So tingnan natin yung proof. Actually, simple lang yung proof ng Rolle's theorem. Okay? So ang part ng ating assumptions ay si function f ay continuous sa closed interval AB. Closed interval AB ay compact. So the extreme value theorem or ang iba pang tawag sa extreme value theorem, nakalimutan ko idagdag dun sa lecture notes, ay Weierstrass theorem. Okay? So yung Weierstrass theorem or EVT guarantees that f will attain a maximum and a minimum on the closed interval AB. Okay, sinasabi niya, sure tayo, meron siyang maximum at saka minimum. Now, kapag yung maximum at saka yung minimum ay nag-occur doon sa endpoints, right? So ibig sabihin yung maximum is either f of A or f of B and the minimum is either f of A and f of B. So yun yung ibig sabihin nitong conjunction na yan. Kapag yung absolute extrema ay nandun sa mga endpoints, then I am sure that f is a constant. Why? Because if the maximum lives on one of the endpoints and the minimum also lives on the other endpoint, equal yung function values nila. So sabi natin f of A, halimbawa siya yung minimum point. F of B siya yung maximum point. So dahil sila na yung minimum, equal silang dalawa, so ibig sabihin wala tayong choice kundi dapat constant lamang yung function doon sa pagitan nila. Kasi pag meron siyang point na mas mababa, ibig sabihin edi hindi na to minimum. Hindi pa rin to minimum, so walang minimum dun sa endpoints. Alright? So talagang persado tayo na dapat constant yung function. Okay? At dahil si f ay constant all throughout the interval, pwede nating tingnan yung limit ng f of x minus f of a. Siguro tawagin natin f of k all over x minus k as x approaches k, where k is any number on the closed interval. Ito yung magbibigay sa atin ng f prime of k, right? By definition. Sabi natin, ang conclusion natin dito, si f ay constant. So ibig sabihin yung f of x ay equal sa f of k. So the numerator here will be equal to 0. So the limit is equal to 0. Actually, this proves na ang limit ng constant, ng derivative ng constant ay equal kay 0. Okay? So that means, okay, nagsi-zero yung derivative sa lahat ng x's doon sa interval na yon. So we're done. Kasi ang claim nga lang ng theorem, may isang number c, may at least isang number c kung saan totoo na nagsi-zero yung derivative. Napakita natin na pag nagsabay yung maximum at minimum dun sa endpoints, sure na tayo na zero yung derivative everywhere. So we're done. So what's left to be proven ay totoo pa rin yung statements kahit na yung minimum o kaya maximum value ay hindi nangyayari doon sa endpoints. Okay? So if at least one of the minimum or the maximum occur at an interior point of the interval, halimbawa yung maximum nanirahan sa isang number c sa pagitan ni AB, not including A and B. All right? Ibig sabihin by the interior extremum theorem, dapat yung derivative at the number c dapat ay equal kay 0. And C is an interior point, so we're done. Napakita na natin na may number doon sa open interval AB na ang derivative ay 0. And specifically, the proof tells us na, hindi lang siya nag-exist. Alam ko kung saan siya nag-exist. Nag-exist siya kung saan nag-maximum o nag-minimum yung function f. So kung ano yung highest point at lowest point, alam ko 0 yung derivative doon. Yun yung number na gina-guarantee ng theorem ni Rolle. Okay? So I guess that's easy for you guys. Siguro pwede ko nga itong ipa-problem set sana. Ano? Kaya lang, na-prove na siya sa lecture notes. So X na yan. So lipad tayo. Papunta sa Mean Value Theorem. Tapos, kung babasahin niyo yung Mean Value Theorem sa inyo, hold on. Parang naisahan tayo ni Rolle. Bakit nagkaroon ng theorem na pinangalan sa kanya, pero specific case lamang yun ng Mean Value Theorem? Kasi anong ba yung assumption ng Rolle's theorem? Kaparehas ng MVT. Continuous yung closed interval AB. Continuous yung F sa closed interval AB. Differentiable yung F sa open interval AB. Tapos yun nga lang, nawala yung condition na si f of A ay equal kay f of B. Pero kung makikita niyo sa Mean Value Theorem, wala siyang assumption na ganun. Okay? Pero kung idadagdag mo yung assumption ni Rolle ng f of B ay equal kay f of A, itong numerator na to ay mag-i-equal kay 0. So basically, sinasabi niya f prime of C is equal to 0. So indeed, you can say that Rolle's theorem is just a specific case of the mean value theorem. In particular, if you throw in the additional assumption that f of A is equal to f of B, then this reduces down to Rolle's theorem. Sabi niyo, bakit ganon? Sumikat si Rolle pero nagbigay lang siya ng specific value ni f of B at saka ni f of A sa MVT. Naging sikat na siya. Bakit ganon? Alright? I'm not familiar with the history, pero there should be a reason kung bakit importante yung Rolle's theorem. Malamang, I'm betting, na naunang ma-prove yung Rolle's theorem kaysa sa mean value theorem, tapos generalize na lang siya. Or kung hindi man yun totoo, itong proof ng mean value theorem na to kasi, ang ginamit niya ay yung theorem ni Rolle's, which might be a little bit peculiar, na parang kakaiba. Di ba sa math, dapat ang reasoning natin ay deductive. Mula sa general, nakakapag-conclude tayo ng specific. Hindi tayo laging nagko-conclude from specific to general. Alright? Kasi nga sabi natin sa math, pag totoo siya sa counting number, counting values, hindi necessarily totoo siya sa lahat ng values. Okay? Pero ang idea kasi nito ay, nagkaroon ng isang creative way. Kumuha siya ng isang function, okay, kung saan na-apply yung Rolle's theorem at mula ron na-derive itong equation na to. So yun yung kagandahan dito na yung maliit na theorem, yung Rolle's theorem, the specific case, was able to prove the larger case, the mean value theorem. Okay? Pero tingnan natin muna graphically, ano yung sinasabi ng mean value theorem. Okay? So katulad lang din siya talaga ng Rolle's. Wala nga lang tong assumption na equal yung function values nila. So halimbawa, ito yung f of A. Kasi B halimbawa nandito, pero ito yung function value niya. Hindi na sila equal na dalawa. And then, tama si Charles. Taylor and Maclaurin series can relate. Ganun din si Maclaurin saka si Taylor. Specific si Maclaurin ni Taylor. But yeah, that's a nice analogy. So okay, So, dapat smooth at continuous yung function over the closed interval AB. Drawing ka lang ng kahit ano dyan. So, smooth yan. Continuous yan. Tapos, ano nga ba yung nire-represent nito? Look at this guy. The right-hand side is actually what we call the mean value or the average value of f on the closed interval AB. Okay, so yun tinatawag natin na mean value ni f sa closed interval AB. So parang kasi in-average natin yung f of b at saka f of a with respect to the length of the interval, ano? But does this remind you of something? Because this guy, pwede mo itong tingnan as change in y, kasi mga function values sila, all over change in x. So parang ano lang to, slope lang to ng line passing through the endpoints. Thank you, Charles. That's correct. So, sige na nga, magkakaroon ka ng bonus dahil dyan. So, yeah. Slope lamang ito ng secant line passing through the endpoints. Okay. So, balik tayo sa drawing. Secant line, secant line. The drawing ko yung line passing through the two endpoints. Okay. So, yan yung line na yan. Ang sinasabi ng mean value theorem ay makakahanap tayo ng isang number doon sa open interval kung saan ang tangent line ay may kaparehas na slope as the secant line. Because f prime of c, ito yung slope ng tangent line sa c, ay equal lamang sa slope ng line passing through the endpoints. So basically, dapat parallel sila, di ba? Analytic geometry is waving na kapag ka-equal yung slopes, dapat sila ay parallel. So, ang kailangan ko lang hanapin ay makapaghanap ng isang point doon sa interval kung saan ang tangent line ay parallel dito sa secant line na ito. And if we do the search, oops, ayaw niya makisama. There we go. Ito yun. Yun. Ito yung number C na ginagarantiyahan. Oops, sorry. Na ginagarantiyahan ng mean value theorem. Ayaw niyang sumulat. Ayun. Yan yung C. Okay? So yun yung idea. Though the mean value theorem doesn't say how many of them ang nag-exist, ilang C's yung posible. Alright? Sabi niya lang, at least merong isa. Okay? Hindi ko na alam kung ilan, pero sure ako meron. Okay. So with that understanding, tingnan natin yung proof. Ano? Oh, you can also, wag na lang. Ulitin ko na naman sana yung ginawa natin sa roles na equal yung f of a sa kay f of b. Na-drawing ko na nga pala siya kanina. So let's look at the proof of the mean value theorem. Okay. At sabi natin, yung drawing mukhang slope ng tangent ng line passing through the endpoints. So mukhang siya yung gagamitin ko. Yun yung clever way kung paano ko yun yung magiging simula ng clever way kung paano ako magagamit si Rolle's theorem para ma-prove itong generic na mean value theorem. Okay. So here we just take note nung two-point form ng line. So yung line passing through the endpoint. So itong line na to, ang equation niya ay ito. So yan yung binigay sa atin ng analytic geometry classes natin. Okay. Because remember, our goal is to find a point on the interval such that the derivative is equal to the mean value. Okay? Tapos ito, tingnan nyo to. Pag dinifferentiate ko to, derivative yan. Tapos ito ay linear function lang naman yan, no? So ang linear function, ang derivative niya ay yung slope lamang. So ang y prime ay eksaktong ito lamang. Okay? Tapos, yan yung gusto ko rito Yan yung gusto kong maging function value ng derivative. Tapos, ito na yung derivative ni y. Okay. So, ang gagawin ko ngayon, dahil gusto kong ito yung maging value ni f prime, okay, at the number c, then magdi-define ako ng isang auxiliary function. Ano yung auxiliary function na i-define ko? O yung props na function? Define ko si d. Siya yung f of x minus that guy. Because again, if I differentiate d, this will be f prime. This will just be this guy, the mean value. And all we want to show is that d prime becomes 0 at some number in the interval. Okay, dapat mag-0 si d prime para kasi pag nag-0 si d prime, Ibig sabihin sa isang number, nagiging 0 itong f prime minus this guy. So that means f prime is equal to the mean value. So nabago na yung goal natin. Napakita natin na ang gagawin ko na lang, ipakita ko na si d prime ay nagiging equal kay 0. Now, kailan ba nagsi-0 si d prime? So si d prime, ito yung computation niya. Pero meron ba tayong tool na makakapag-conclude na ang d prime ay equal kay 0? Actually, marami na. Meron tayong interior extremum theorem. Kaya lang, pag interior extremum theorem, kailangan tingnan mo yung maximum at minimum. Kasi kung meron kang maximum at minimum, sure tayo yung derivative ni d ay magiging equal kay 0. But that will require knowledge about the maxima and the minima na hindi natin alam so far. So ano yung susunod? Yung huli ko nang naalala ay yung Rolle's Theorem. Kaya lang, anong kailangan doon? Dapat continuous si D sa closed interval AB, which is fine because F is assumed to be continuous on the closed interval AB. Oh, this is a polynomial and that's differentiable everywhere. So that means D, being the difference of two continuous functions, will also be continuous on the closed interval AB. Moreover, F is assumed to be differentiable on the open interval AB. This guy is a polynomial, so it is differentiable everywhere. So D, being the difference of two differentiable functions, will be differentiable on the open interval AB. Okay, so all right, so nasatisfy niyo yung mga conditions na yun ni Rolle's Theorem. Isa na lang yung kulang para magamit natin yung Rolle's Theorem. Dapat yung D of A at saka yung D of B ay equal sa isa't isa. Okay? Tapos pag jackpot na totoo yun, ibig sabihin si D prime ay magsi-0 sa isang number C doon sa open interval AB. Okay. So compute natin D of A at saka D of B, hoping that they will be equal to each other. So if I plug in A, lahat ng X papalitan ko ng A. Oh, this is a nice thing. I'm gonna have A minus A. That's 0. Entire first term will become 0. F of A minus F of A, D of A is 0. Now, we are keeping our fingers crossed na dapat yung D of B mag-0 rin. Para equal yung function value sa magkabilang dulo and Rolle's will kick in, right? So, compute natin yung D of B. Lahat ng X, palitan ng B. B minus A. Makakancel niya yung B minus A sa baba. Tapos, matitira na lang ay F of B minus F of A. Kaya lang may plus F of A dito. That will make this 0. And then F of B minus F of B, that will be equal to 0. So D of B vanishes as well. Okay? So, yes, naging equal sa 0. Parehas yung D of A at saka D of B. Equal yung function value sa endpoints. Then Rolle's theorem will kick in. We know that there will exist a number in the open interval AB such that the derivative vanishes. Now, 0 yung derivative. Okay, alam ko yung derivative. Eto siya. Pag nag-plug in ako dyan ng C, magiging 0. Here we go. Plug in C here, that will become 0. And then transposition will give us the desired equation. The existence of an intermediate point that will make the derivative equal to the mean value. Okay, end of proof. Sana ganito lang yung mga proofs, no? Pag tayo na yung nagsusulat. Ang crucial point kasi dito, maiisip natin ito, na i-define, na kukunin ko yung slope nung, kukunin ko yung equation ng secant line, tapos i-define ko yung function D ng ganito yung paraan. Kaya nga sabi sa analysis nga, parang 90% ng proof ay magko-construct ka muna ng isang object, isang suitable object for your purpose. And everything will follow nicely directly using the previous results. Okay. So ano ngayon? Ano yung mga implications? Sabi ko nga, pangako ko kanina, hindi lang pahirap yung MVT. Meron yung saysay, meron yung significance kasi marami mga results ang nanggaling sa MVT. One of them is Corollary 4.1, which is basically the converse of what we have accidentally proven kanina. Na-prove natin na ang limit ng, ang derivative ng isang constant function ay laging equal kay 0. Now, it's nice to ask, hindi ba pwedeng gawin nating if and only if yun? Baka naman totoo rin yung converse. Kasi na-prove natin ay constant function implies zero derivative. Now, if we know that the derivative is always 0, Does it follow na constant yung function na dinifferentiate natin? And the answer is yes, sabi ni Corollary 4.1. Kapag ka meron kang isang function na zero yung derivative on its domain or on an interval, then that function is constant all throughout its domain or that interval respectively. Okay? So yun yung sinasabi ng Corollary 4.1. Now, tingnan natin paano siya naging corollary ng MVT. Now, ang gagawin kong proof ay kukuha ako ng dalawang elements. Tawagin natin x at saka y ng interval I. Hindi pa directly magagamit yung Mean Value Theorem kasi ang condition lang ang assumption lang dito ay si G ay differentiable sa isang interval I. Hindi ko nga alam kung si I ay open interval o closed interval o half open or half closed. So hindi ko siya ma-apply kagad dito kay I. Okay? Pero ang gagawin ko ngayon, kukuha ako ng dalawang arbitrary o dalawang random. Pipili lang ako ng kahit anong dalawang numbers dun sa interval I. Tapos without loss of generality, I will assume that x is less than y. I will not lose any generality here because if x is greater than y, edi pagpapalitin ko lang sila ng pangalan. Alright? So pagpapalitin ko lang sila ng label. So basta yung mas maliit siya yung tatawagin kong x, yung mas malaki siya yung tatawagin kong y. Okay. Now, dapat meron ako ditong insert na idea. So, G is differentiable on I. So, G is differentiable on I. This will imply that G is differentiable at every number on the interval I. So, kung siya ay differentiable sa lahat ng number sa loob ng interval I, then that means G will be differentiable on the closed interval AX. Or actually, kailangan ko lang yata ay open. So for sure, this would be differentiable on the open interval AB. Tapos ano pa yung alam ko? Si G ay differentiable kay I. So si G ay magiging continuous. So ito yung isa pang implication. Si G ay magiging continuous kay I. So siya ay continuous kay I. So ibig sabihin continuous siya sa lahat ng number kay I. So siya ay continuous sa lahat ng subsets ni I. In particular, we will be sure that G is continuous on the closed interval XY. Hindi pala dapat AB. Bakit AB ang ginamit ko? Si XY nga pala yung pinag-uusapan natin. Alright? Kasi nga kung ito si I, kung ito yung interval I, pipili ako ng X, pipili ako ng Y, dito ko gagamitin yung MVT dun sa closed interval X, Y. Okay? So, appealing to the mean value theorem, we know that since the premises are satisfied, we know that there exists a number C on the open interval XY. So, nandito si C sa loob na yan. Okay? Such that the derivative at the number C is equal to the mean value of G over the interval XY. So, mean value theorem lang yan. Tapos part ng assumption natin, sabi natin, ang assumption dito, zero yung derivative sa lahat ng numbers dun sa interval I. So that means this is equal to 0, okay? And a quotient will be equal to 0 if and only if the numerator is equal to 0. So that means gy must be equal to gx. Okay? So si gy ay equal kay gx for all k. For some k. So parehas lang sila ng value. Ano ngayon, kung parehas yung value nila, ang goal natin dapat magpakita na pare-parehas ng values lahat ng points dun sa interval I. Pero remember that x and y were chosen arbitrarily. X and y can be any number on the interval AB. And no matter what x and y are, as long as they belong on the interval I, they will share the common value k. So ibig sabihin, si g of x ay necessarily equal kay k sa lahat ng number doon sa interval I. Therefore, proving corollary 4.1. Kasi ito na yung napaka-useful na result na ginagamit natin siya sa ODE, sa PDE, and so on, na kapag ka zero ang derivative all throughout, nangyayari lang yon if and only if yung function na differentiate mo ay constant. Okay? Now, isa pang mahalagang implication ng Mean Value Theorem ay yung Corollary 4.2, which tells us na ito naman yung nangyayari na ano kaya yung relationship ng dalawang functions na equal yung derivatives, all right? So if we have two functions, f and g, whose derivatives are equal to each other, does it necessarily mean that f and g are equal to each other? Actually, no. The answer is not always, okay? But the guarantee is, hindi man sila yung dalawang functions equal sa isa't isa, meron silang magandang relationship. They only differ by a constant all throughout the interval. Tapos ito yung ginagamit natin, ito yung dahilan kung bakit lagi tayong naglalagay ng plus c doon sa value ng integral. Okay? Kasi nga, sabi natin yung integral, siya lang yung antiderivative. So naghanap tayo ng function na pag dinifferentiate mo, ang sagot ay yung integrand. Okay? So the thing here is, kapag ka equal yung derivatives, hindi necessarily equal yung kanilang antiderivatives. But the guarantee is, yung difference between those antiderivatives ay lagi lamang isang constant. Kaya naglalagay tayo ng plus c pag nag-i-integrate tayo. Okay? Now, the proof is left as an exercise, but I think it's pretty straightforward. Binigyan pa nga tayo ng hint na ang auxiliary function natin na gamitin ay f of x minus g of x. Now, let's sketch the proof or mag-prove tayo sa hangin. Hindi pala ngayon pwede sa hangin kasi yung pag-prove sa hangin, parang yung teacher mo nagwo-wand lamang ng nagwe-wave lang ng kamay niya habang nagle-lecture. Actually, ginagawa ko siya ngayon. Ang dami kong hand gestures. Buti lang na nagsosolo ako sa kwarto. Wala makakita. Baka pag-isipan akong nasiraan na ng bayat. Pero pwede natin siyang i-prove without writing any specifics. So, kayo na lang yung maglagay. So, gagamitin ko yung Mean Value Theorem. Mean Value Theorem nga ba gagamitin ko? Actually, I think Corollary 4.1 will be sufficient to prove Corollary 4.2. Kasi ngayon, gamitin ko raw ito. What do I know about the function h? Well, the function h is differentiable on the interval I because it is the difference of two differentiable functions f and g. And not just that, the derivative of this guy is what? F prime of x equal to f prime of x minus g prime of x. But hold on, we have the assumption that the two derivatives are always equal. So that means this guy is equal to 0 for all x in the interval I. So nakita natin ngayon ang derivative ni h ay laging equal kay 0 sa buong interval I. So Corollary 4.1 is telling us, h must be a constant. So we can say na, kunwari si h of x ay equal kay k for all x in the interval I. So ibig sabihin, ano ba si h? Si h ay f of x minus g of x. Equal daw yun kay k. Transposing gx to the other side will give us the desired equality. Okay? So pag nakakita kayo ng dalawang functions na equal ang derivatives, ibig sabihin, nagdi-differ sila by a constant. And the constant need not be equal to 0. It could be, say, pi over 2, kasi yung mga classic examples, mga trigonometric functions. Okay? So, yeah. Merong possibly non-zero constant na value ni k. Parang nung Math 36, sinanggap lang natin as gospel truth yung Corollary 4.2. And that is crucial in the theory of indefinite integrals. Okay? Sige, dalawa na lang yung natitirang theorems na kailangan nating i-prove bago natin isarado ang chapter na ito ng 155. Dalawa na lang, guys. So, siguro 2-minute break muna tayo. Excited na rin ba kayo sa June? Excited na ako sa June kasi at least hindi na sana ganun kainit. Pero yun lang yung excitement about June. Oh, by the way, hindi ko pa pala na-upload yung recording nung klase last Tuesday. Kasi nga nawalan ako ng internet kahapon. Saka nasasayangan ako dun sa data. Kung gagamitin ko yung mobile data ko. Nag-subscribe lang ako sa ano nga ba yun? GoSurf 50 lang yata yun na 3 gig. 5 gig hanggang in 3 days. So, yeah. Gusto kong tipirin kasi baka mag-lecture ako ngayon at bukas na gamit yung mobile data. But luckily, bumalik yung internet namin. So I'll upload the recording of that lecture later today, probably after we close the session. Meron akong sasabihin kaya lang nakalimutan ko. Sign of aging na ba ito? Yeah, hindi ko na matandaan. So now, balik na nga tayo. So let's continue on. Dalawang theorems na lang naman ito. Yung unang theorem is the generalization of the mean value theorem. Pero mas general siya una kasi dalawang functions na yung involved. We are assuming two functions, f and g, that are both continuous on the closed interval AB and differentiable on the open interval AB. Okay? Then the guarantee is, meron pa rin tayong mahanap na number C doon sa interior ng interval that will satisfy this equation. Okay? So, ano yung sinasabi nito? Yung change from endpoint to endpoint ng function f ay proportional doon sa endpoint to endpoint change doon kay function g. Tapos yung constants of proportionality natin actually ay yung derivative ni g sa isang special number c doon sa interval AB at saka yung derivative ni f doon sa isang special number or to the same special number on the open interval AB. Okay? So merong relationship, yung pagbabago ng function values sa dalawang functions g, f and g sa isang interval AB. And that relationship is summarized by this equation over here. Now, if g prime is never 0, that means pwede tayong mag-divide both sides by actually double check ko nga kung sufficient na si g prime lang yung never 0. Kasi typo ito dapat ay g prime. Kasi ang gagawin ko ay divide ko both sides by g prime. So ito ay magkakaroon ng g prime. Ito ay magkakaroon ng divide g prime of c. Okay. So maka-cancel ito. Tapos magdi-divide pa rin kasi ako ng g of b minus g of a. So lagi bang define yung g of b minus g of a? So yun yung kailangan kong isipin. Kung sufficient na si g prime ay nag-never equal kay 0, then totoo ba na dapat hindi na rin magsi-0 yung g of b minus g of a? Because otherwise, this quotient will not be defined. But assuming that everything is fine, specifically g prime of c is not 0, nor g of b minus g of a equal to 0, then this is true. Na yung ratio between the instantaneous rates of change at a specific number c on the open interval AB ay equal lamang sa relative change between the f and g values on the respective endpoints or from endpoint to endpoint. Okay. Now, bakit siya generalized mean value theorem? So hindi lamang dahil nag-consider tayo ng dalawang functions, so mas malaki yung scope ng GMVT, pero ang isa pang dahilan ay yung mean value theorem ay isa lamang specific case ng GMVT. Okay? Paano natin ma-realize yung MVT from GMVT? Kailangan lang nating iset si g of x ay equal kay x. So specific case, si g of x ay equal kay x. So si g of x equals x ay continuous pa rin naman at saka differentiable, so that's fine. Mag-hold talaga yung GMVT. Okay? So sa GMVT, so si g prime ay equal lang kay 1 regardless of the number x you put into g prime. Laging 1 yung derivative na makukuha natin dun sa identity function g of x equals x. So ibig sabihin itong derivative na to mapapalitan lamang yan ng 1. So wala na siyang effect sa multiplication. Tapos ano pa nga ba? Well, si g of x ay equal kay x. So ibig sabihin si g of b ay equal kay b at si g of a ay equal kay b. Ay equal kay a. So this guy becomes b. This guy becomes a. So we have a b minus a on the right side. And once we divide both sides by b minus a, makukuha natin, f prime of c equals f of b minus f of a all over b minus a. Okay? So kaya specific case ng MVT, ng GMVT ang MVT. Now, paano natin to ipoprove? Apparently, ang proof niya, babalik na naman tayo kay Rolle's Theorem. Makikita niyo na ngayon, deserve naman pala ni Rolle na mabigyan ng pangalan yung theorem niya or may pangalan sa kanya yung specific case. Kasi hindi lang siya pinang-prove ng MVT, pinang-prove pa siya nung generalized MVT. And how can we do that? Well, ito daw yung i-consider natin. Oops. Ito yung auxiliary function na gagamitin natin. Bakit yun, sir, yung gagamitin natin? Let's see. Okay, bakit nagbe-make sense na ito yung gamitin? Okay. Pag kinuha ko yung derivative ni h, equal lang siya dito, f of b minus f of a. Constant kasi yan, di ba? Scalar multiplier to, constant yan. Tapos multiply ko lang siya ng derivative ni g minus constant times derivative ni f. Okay? Tapos kung makikita nyo, okay, ito yung left side ng equation sa GMVT, ito yung right side. So, para mapatotohanan yung conclusion ng MVT, kailangan lamang ang target natin ay ito ay maging equal kay 0. For some x equals c. So, at x equals c. Yan yung goal natin. Kasi once we are done with that, then we're good. But how can we show that that is equal to 0? Well, kailangan na natin ipakita na nagsi-0 yung derivative at some number in the interior. Okay? At ano nga ba yung tool natin na makakapagpakita na yung derivative ay nagsi-0? And that is Rolle's Theorem. Okay? Sabi ni Rolle's Theorem, kapag continuous yung function sa closed interval AB, tingnan nga natin kung continuous si h sa closed interval AB. G is continuous on the closed interval AB, F as well. So these two guys are both continuous. So H, as a difference of two continuous functions, ay nagiging continuous din sa closed interval AB. On the other hand, okay, differentiable si G on the open interval AB, differentiable si F on the open interval AB by assumption. So h is the difference of two differentiable functions on the open interval AB. So h must also be differentiable on the open interval AB. Okay? So, okay, 2 down. Dalawang requirements ng Rolle's Theorem na satisfy niya na. Okay. Tingnan naman natin yung pangatlong condition. Yung pangatlong condition, dapat yung h of a ay equal kay h of b. Okay. So, copying ko to. Okay. Magpa-plug in ako ngayon ng A at saka B para kay X. So lahat ng X, palitan ko ng A. So ito ay magiging A. Ito ay magiging A. Tapos magkakaroon ako ng ano. Tama ba? G prime, G prime. Bakit kay G prime? Sorry. Ang kailangan nga pala mag-equal ay yung function values lang, no? So, hindi to prime. So, kailangan nating i-check ay kung si h of a ba ay equal kay h of b. So, tingnan natin to. Simplify nga natin. Oh, look at this. I'm gonna have negative f of a times g of a. Tapos dito meron ako negative g of a at f of a rin. Kaya lang may minus sila sa pagitan, so magka-cancel out yung mga terms na yon. So matitira lamang dito ay f of b times g of a minus g of b times f of a. Right? Tapos ulitin ko yan, pero ang ipa-plug in ko naman ngayon ay x equals b. X equals b, x equals b. And then let's see what terms will cancel each other out. Oh, meron akong f of b times g of b dito. Tapos meron akong g of b, f of b here, exactly the same, pero merong minus sign sa pagitan nila. So ibig sabihin, ang matitira na lamang ay negative f of a, g of b, tapos ano nga yung na-cancel sa kabila? Okay, magkakaroon ng minus, magkakaroon ng plus, g of a, f of b. And this is exactly this guy. Okay? So lahat ng conditions ng Rolle's theorem ay na-satisfy. So that means there exists a number c in the open interval AB such that f prime of c is equal to 0. And that ends our proof. Because if h prime at c is equal to 0, then na-attain na natin yung goal na in-specify ko kanina. Right? So kompletuhin nyo na lang yung natitirang part ng proof. Right? Plug in c here, makikita nyo, okay, makuha ko na yung equality na gusto natin from MVT. Okay? Questions bago tayo pumunta sa huli? Okay, kung wala naman, so last na to. So L'Hopital's rule. So kasi nga gusto kong ipakita talaga sa inyo na ang daming implications ng Mean Value Theorem at ang Generalized Mean Value Theorem. At isa sa kanila yung rule, yung L'Hopital's rule na ginagamit natin para sa pag-evaluate ng limits of the form 0 over 0. Kung natatandaan nyo, saan nyo nga ba ito nakita? 37 ba? 30? Kung na matandaan kung saan ito natuturo ngayon. 36, 37, o 38. Pero alin man sa mga yon, pag nag-evaluate tayo ng limit ng f of x over g of x, tapos pagka nag-direct substitution ka, naging 0 over 0, sabi natin, oh, indeterminate yan. At isang paraan para ma-evaluate yung limit niya ay gumamit ng L'Hopital's rule. And sabi sa L'Hopital's rule, yung limit ng f over g ay equal sa limit ng f prime over g prime. And hopefully, pag-evaluate ng limit ng f prime over g prime, wala na yung indeterminate form. Hindi na siya magzi-0 over 0. Okay? So, dati tinanggap lang natin, okay, so sir, dahil mas madali yan, sige na nga, tatanggapin ko na yan as isang gospel truth. Ano? Pero ngayon, i-prove natin yung at least yung 0 over 0 case. Makikita nyo, gagamit tayo ng Mean Value Theorem. So, but first, let's formally state L'Hopital's rule. So we are assuming f and g to be continuous functions on an interval containing a. And then further, we will assume that f and g are differentiable on that interval with a possible exception at the number a, right? And then if f of a is equal to 0 and g of a is equal to 0, yung limit ng quotient ng derivatives ay equal dun sa limit ng quotient ng original functions. Kaya lang hindi kasi natin magamit yung continuity ni f at saka ni g dito sa original problem. Kasi pag ginamit natin yung continuity, ito ay magiging 0, 0 over 0 is an indeterminate form. Okay? Pero kapag tinignan mo yung f prime over g prime and you evaluate the limit as x approaches a and you got a number L, then the limit of f over g is also equal to L. And then let's see how we can prove it. Okay. Now we will be proving an implication. So the antecedent of the implication becomes part of our assumption. So, and that's where I will start. I will use the definition of the limit for f prime over g prime. Dahil yung limit ni f prime over g prime as x approaches a ay equal kay L, then given any epsilon greater than 0, we are sure that we can find a delta greater than 0 such that for any number t, nag-change lang ako ng variable instead of x, ginamit ko si t. Kasi ginamit ko yung x dito sa original problem eh. So, gumamit ako ng dummy variable t. So, kahit na anong number t na nasa delta neighborhood ni A, laging yung f prime of t over g prime of t ay nasa epsilon neighborhood ni L. Okay? So, basically, these two lines, ginamit ko lang yung definition ng limit ng f prime over g prime. Okay? Now, ang gagawin ko ngayon, dito sa specific delta na ginamit natin dun sa epsilon na given, magko-consider ako ng isang number x that is inside the delta neighborhood nung ni A. So halimbawa, ito si A, ito yung delta neighborhood niya, A minus delta, A plus delta. So sabi sa kahit anong t, o yung sa kahit anong t values dyan, totoo itong epsilon inequality, right? So ang gagawin ko, pipili ako ng isang x dun sa delta neighborhood. Okay? So I will choose initially an x that is larger than a. So halimbawa, ito si x. Nandun pa rin ako sa delta neighborhood. Tapos kung ang napili mo na x ay nasa kaliwa, then makakarating tayo sa same conclusion with similar and analogous arguments. So kaya nga it suffices na lang na gawin ko yung proof para sa si x ay mas malaki kaysa kay A. Alright? But nevertheless, that choice of x still belong to the delta neighborhood. So ibig sabihin totoo ito. Okay? So dahil totoo yan, nawala din naman ako sa flow ng proof. Okay. So, iset aside muna natin ito. So, set aside muna yan. Tapos, ang gagawin ko ngayon, gagamitin ko yung Generalized Mean Value Theorem kay f at saka kay g, pero sa closed interval a, x. I think ito lang yung dahilan kung bakit ko inassume na si x ay mas malaki kay a, para masulat ko yung closed interval ng tama. Kung si x ay mas maliit kay a, or para sa mga x's na mas maliit kay a, ang gagamitin ko yung GMVT naman sa x, a. Right? So, dun lang sa arrangement. Kaya kailangan ko kung sino yung mas malaki between kay a at saka kay x. Now, gamitin natin yung Generalized Mean Value Theorem kay f and g. So, we know that there exists a number c on the open interval ax such that this is true. So, ang f prime over g prime at the number c ay equal dito sa ratio ng ng endpoint to endpoint differences. Okay? Kaya lang, sinabi natin sa assumption, f of a ay equal kay 0, g of a ay equal kay 0. So, this vanishes. This also vanishes. So, ibig sabihin si f prime over g prime of c ay equal lamang kay f of x over g of x. Okay? And this is true for any x within the delta neighborhood of A. Okay? Tapos ano pa yung alam natin? Oh, si C ay nasa open interval AX. So, ibig sabihin, nandito si C, somewhere here. Dahil si C ay nandun sa loob na yan, okay? Nandun pa rin siya sa loob ng delta neighborhood. At alam ko sa lahat ng numbers dun sa delta neighborhood, kapag nagiging totoo itong inequality na to. So that means this inequality is true when t is replaced by c. So we have this epsilon inequality. Pero sabi natin kanina, na-discover natin na yung f prime over g prime of c ay equal kay f of x over g of x. So that means this is exactly this guy. So in other words, this is less than epsilon whenever this is true. And remember, we did this for an arbitrary epsilon greater than 0 and found a delta greater than 0 such that if this is true, then this guy is less than epsilon. That's the very definition ng limit ni f of x over g of x. And what is the limit? The limit is equal to L. So therefore, yung limit talaga ni f over g ay equal kay L. Okay? And yan na. Tapos na tayo sa Unit 4. Bilis ng Unit 4, no? 2 sessions lang. Hindi ko matandaan kung ilang sessions yung kailangan ko para matapos yung Unit 5. Pero yun nga, if you finish early, or even if we don't finish early, I can probably give you problem set number 3 in advance para pwede nyo siyang unti-untiin. Okay? Pero for now, tapusin nyo muna yung problem set number 2. Meron kayo hanggang linggo para tapusin yon. Tapos dahil pahirap ako, bibigyan ko kayo ng homework sa Monday, 8 a.m. Expect it on Canvas na ang deadline naman ay Wednesday ng midnight. Okay? Tapos, after nun siguro, problem set naman kasi ayoko kayong makapagpahinga. Hindi, joke lang. So wala kasi tayong choice. Ano? Okay, any other questions, concerns?